Calcium is essential to tree growth because it promotes the formation of wood and maintains cell walls. In 1990, the concentration of calcium in precipitation in a certain area was 0.15 milligrams per liter. A random sample of 10 precipitation dates in 2007 results in the given data table up here. We want to state the hypotheses for determining if the mean concentration of calcium precipitation has changed since 1990. So for this we have a null hypothesis of that the mean precipitation was 0.15 milligrams per liter. So it's equal to 0.15. The alternative is that we want to see if it has changed. So the mean would not be equal to 0.15. And we want to know, does the sample evidence suggest the calcium concentrations have changed since 1990? So we need our data table for this, which this will be up on Blackboard, but I have that here in this Excel document. I'm going to copy this and paste it into this template. And we have here that the test population mean is 0.15, and the level of significance, which I did not give a specific value for, but why don't we give a specific value, even though we already have a p-value. But let's give alpha a value of 5%. So 5%. All that does is just changes this conclusion in here. But we have here a p-value of, well, we first have a t-statistic. Maybe we'll put that first, of 0.04. And a p-value of 0.9688. So based upon that value of the p-value of 0.9688, we know that that is indeed greater than, that's going to be greater than 5%, right? It's a lot greater than 5%. It's nowhere near 5% for that matter. So the conclusion that we can make for this, is at the 5% level of significance, we do not have sufficient evidence to reject the null hypothesis. So then that means then the mean concentration of calcium precipitation has not changed since 1990. So mean concentration of calcium precipitation has not changed since 1990.